Recently, I have salvaged this power supply from a damaged printer. This is a switch mode power supply, SMPS for short. This power supply is an efficient type of a power supply. After having an inspection, it's in a good condition, so I plug it to the mains, and the output voltage, which is, you see, is 42.9 volts DC. But as an electronic enthusiast, we need a wide range of voltage, right? Alright, but you can say, hey, just buy an adjustable boost or buck converter and connect it in the output. But you may also ask, can we just modify its circuit to change the output voltage? Let's find out. Actually, the answer to that question is that it depends. It depends on the circuitry of your SMPS power supply. But in this video, in my case, I have only tried this with simple power supply, like this with an optocoupler. We should know the basics of switch mode power supply. I traced the circuitry and basically composed of these parts. But to simplify, we will talk about it in the feedback circuit, which is in the isolated output side. It is composed of a Zener diode for the reference voltage and an optocoupler. So what it does is to send a signal to the controller circuit to lower or higher the PWM duty cycle. So a steady or constant voltage will be generated in the output. To understand it better, let's go to the every circuit app. To simulate the feedback circuit in the output, we see a Zener diode here, and to know its voltage rating, we need to connect the SMPS to the mains, and we see a 6.5 volts, and that is its voltage rating. We're gonna put on the simulator. We have here a power source to simulate the output voltage. Since there's no optocoupler in this simulator, we will just use an LED since you know an optocoupler has an LED. So first, we will slowly increase the output voltage just like plugging in a power supply because everything will start at 0 volts. Now, we can see how this feedback circuit reacts to the output voltage. And we see that the LED lights up when their voltage reaches near 45 volts. And in our simulation, the LED is now on, so this means it will lower the duty cycle. So after lowering the duty cycle, it will now stop increasing the output voltage, meaning to say the voltage will stabilize about 45 volts. But in the real circuit, it limits the output to 42.9 volts, which is close enough to the simulation. And now you know how it works. Now, to change the output voltage, we will do this. But one important note, I don't recommend changing the output voltage to be higher than the original because this will destroy the components, because the components are usually rated to the original voltage, so just make it lower. So now we can change the voltage by changing the voltage divider network, either one of these resistors. So if we calculate the output voltage on the middle, it's 7.13 volts. We will call this as the VREF, and it can be confirmed by probing to it. It's close enough, but we will use this in the calculation. By plugging it to our equation, this is the desired voltage you want. In my case, I want 15.4 volts and then the VREF, so we will replace R1 with 10.8K resistor. To have this, I just combine these 3 resistors in series in a parallel, which is just close to 10.8K. So I soldered it to the board, and if we measure the output capacitor, the voltage is now indeed about 15.47 volts. Nice! And yes, if you want it to be adjustable, we can just also put a 10K potentiometer here, and we have now an adjustable voltage. So that's how to change the voltage of a switch mode power supply. Thanks for watching. I hope you learned something new today. Subscribe to this channel, and remember, be innovative.